A supernova may have caused mass extinction on our Earth. This is what scientists have now claimed. The team of researchers led by Professor Brian Fields hypothesizes that a supernova about 65 light-years away may have contributed to the ozone depletion and subsequent mass extinction event of the late Devonian period, which was about 359 million years ago. Now, pictured, we have a simulation nearby supernova colliding with and compressing the solar wind, Earth's orbit, the double blue dashed circle, and the sun, the red dot, are shown for scale. And here we have it. Okay, the blue dot dash circle is Earth's orbit and the sun. Now imagine reading by the light of an exploding star, brighter than a full moon. It might be fun to think about, but this scene is a prelude to a disaster when the radiation devastates life as we know it. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. Killer cosmic rays from nearby supernova could be the culprit behind at least one mass extinction event, researchers said, and finding certain radioactive isotopes in Earth's rock record could confirm that this took place. A new study led by University of Illinois, Urbana-Champaign astronomy physics professor Brian Fields explores the possibility that astronomical events were responsible for an extinction event 359 million years ago at the boundary between the Devonian and Carboniferous periods. The paper was published Proceedings of National Academy of Sciences. The team concentrated on the Devonian Carboniferous boundary because those rocks contain hundreds of thousands of generations of plant spores that appear to be sunburnt by ultraviolet light. This is evidence of a long-lasting ozone depletion event. Fields said Earth-based catastrophes such as large-scale volcanism and global warming can destroy the ozone layer too, but evidence for those is inconclusive for the time interval in question. Instead, we propose that one or more supernova explosions about 65 light-years away from Earth could have been responsible for the protracted loss of ozone. He says, to put this into perspective, one of the closest supernova threats today is from the star Betelgeuse, which is over 600 light-years away and well outside of the kill distance of 25 light-years. This is what graduate student and study co-author Adriel Artel says. Graduate student study co-author Jess Miller said, the team explored other astrophysical causes for ozone depletion, such as meteorite impacts, solar eruptions, and gamma-ray bursts, but these events end quickly and are unlikely to cause the long-lasting ozone depletion that happened at the end of the Devonian period. A supernova, on the other hand, delivers a 1-2 punch, the researcher said. The explosion immediately bathes Earth with damaging UV, X-ray, and gamma rays. Later, the blast of supernova debris slams into the solar system, subjecting the planet to long-lived radiation from cosmic rays accelerated by the supernova. The damage to Earth and its ozone layer can last for up to 100,000 years. But fossil evidence indicates a 300,000-year decline in biodiversity leading up to the Devonian Carboniferous mass extinction, suggesting the possibility of multiple catastrophes, maybe even multiple supernova explosions. Miller said this is entirely possible. Massive stars usually occur in clusters with other massive stars, and other supernovae are likely to occur soon after the first explosion. The team said the key to proving that a supernova occurred would be to find the radioactive isotopes plutonium-244 and samarium-146 in the rocks and fossils deposited at the time of the extinction. Neither of these isotopes occurred naturally on Earth today, and the only way they can get here is via cosmic explosions, said undergraduate student Zhenghe Liu. The radioactive species born in the supernova are like green bananas, Field says. When you see green bananas in Illinois, you know they are fresh and you know they did not grow here. Like bananas, Pu-244 and Samarium-146 decay over time. So if you find these radioisotopes on Earth today, we know they are fresh and not from here, the green bananas of the isotope world, and thus the smoking guns of a nearby supernova. Researchers have not yet searched for plutonium-244 or samarium-146 in rocks from the Devonian Carboniferous boundary. Field's team said its study aims to define the patterns of evidence in the geological record that would point to supernova explosions. The overreaching message of our study is that life on Earth does not exist in isolation, Field said. We are citizens of a larger cosmos, and the cosmos intervenes in our lives, often imperceptibly, but sometimes ferociously. This was originally from phys.org by Louis Yoxolian, and more information on supernova triggers for Devonian Proceedings of National Academy of Sciences, 2020. This is on Bended Reality. Please leave your comments and thank you for your support.